Welcome, grade 10. We're going to look at some more Euclidean geometry. My experience is that pupils, when they see Euclidean geometry, they start freezing up a little bit. They don't like Euclidean. Some do love it, but I know many don't like it. So if I show you how to approach it, I would like you to try and enjoy Euclidean geometry. It's pretty much just telling a story. So we're going to see what story can we tell here. Now, before we're going to do our Euclidean geometry and tell a story, we must know how to prove something is a parallelogram. If I give you a shape like this, the one way of proving something is a parallelogram is by proving that two pairs of opposite sides are equal. Two pairs of opposite sides are equal. A second way of proving a parallelogram is by proving that one pair of opposite sides are equal and parallel. One pair of opposite sides are equal and parallel. A third option is by proving that two pairs of opposite sides are parallel. Two pairs of opposite sides are parallel. Okay, fourth one. If you can somehow prove that the opposite angles are equal, that angle is equal to this one, and this angle is equal to that one. If you can prove that two pairs of opposite angles are equal. And the fifth one, if you can prove that the diagonals bisect each other, meaning that that piece and this piece is equal, and that little piece and this little piece is equal, that the diagonals bisect means cuts in half each other. And I know it will be a parallelogram. So depending on the given information on your drawing and on your sum, that will depend and tell us which of these 5 proofs we are going to make use of. So let's look at the first sum. Now, if you look at this one, it says in parallelogram. So it tells us it's a parallelogram. So now, because we know it's a parallelogram, we're going to fill in and go wild with all the properties of a parallelogram. Opposite sides are equal. Opposite sides are parallel. Please note, with parallel, you always indicate with an arrow. And if sides are just equal, you just indicate it with a line. Opposite angles are equal. Can you see, if you look at this drawing, we don't have a diagonal. So I'm not going to bother with diagonals bisect each other. But I am now going to fill in opposite sides are parallel. And I always like to, if they split it up into 2 triangles, I'm going to show the parallel lines here as well. That line is parallel to that one. This side will be equal to that side because it's opposite sides of a parallelogram. And keep in mind, opposite angles are equal, right? So just keep this in the back of your head. Let's look at the given information. It says that AB, here's AB, is actually equal to BE. Okay, equal to BE, and that's also equal to DE. So if I look at this triangle, what jumps into my brain here is angles opposite equal sides, an isosceles triangle. So I know that angle and this angle will be equal. What else? They say here, calculate the size of D1. So it means we must figure out the size of X. And they also tell us that A1 is 28 degrees. So we fill it in on the drawing. Always fill it in on the drawing. It's like a new world going up, opens up for you, because then slowly it's like a puzzle. You start seeing the whole picture. But if you don't fill it in on the drawing, you will never see the picture. Okay, let's see now. We must do what? We must figure out the size of X. So it means we're slowly going to work with the given information and try and get to X. In this triangle DEC, I've got no information. So it's useless. I can't even start there. Did I fill in everything? D1? Yeah. So the only angle I have is the 28. So from here, I can say that E1 will be 28 degrees. Can you see? Because it's angles opposite equal side. Some of you will say it's base angles are equal. It's fine. You can also say base angles are equal. I'm going to start by saying angle A1 is equal to angle E1 is equal to 28 degrees. Angles opposite equal sides. You must give the reasons. And I'm going to specify AB is equal to BE and fill it in on the drawing. Then what else can we work out? We can actually work out angle B now with the interior angles of a triangle. So A plus B plus E1 is equal to 180 degrees. Interior angles of a triangle. And then we just fill in the actual values. And this will give me 56 degrees. And therefore, angle B is equal to 124 degrees. If you take away 56, fill it in on the drawing. It's very important. So that one is 124. So now we know that D1 plus D2 will actually also be equal to 124 degrees, but we're not using it yet. So what else can we say from here? I know we're working with parallel lines. So I see now, you see, it's like you work from what you just worked out, and you slowly use that information. It's like building a wall. So I just figured out this one, and now I'm still, trying to say something about maybe E1 or angle B. So I see here that I can say E1 is equal to A2 because it forms alternate angles, you see, because it's parallel lines. So I'm going to say that. It's not that I can see the answer already. That's what you must understand. Pupils like to be able to think, I can see immediately what's the answer. But you can't always see the answer. So you just try and say something about, where you are at the moment. And then, as I said, then the picture opens up. Angle E1, I can say is equal to A2. That's 28 degrees because it's alternate angles. And, when you write an essay, some pupils get a better mark for their essay and some don't get such a good mark. So it just depends on how well you write your essay, how well and in what logical order you write down everything. But the teachers are kind and they will check and see what was your storyline. So I've got E1, I wrote this, And now I'm going to say that angle C, see, I want to actually work with C because then it's closer to get to X. So I'm going to work with these angles that will be equal. So 28 plus 28 is 56. So I've got my angle C. Angle C will be equal to A1 plus A2. Why can I say it? Because it's the opposite angles of a parallelogram are equal. Right, so now we have that one. And the next step that I'm going to do here is I'm going to prove that this side and this side is equal. Can you see on the drawing? It's very easy to see. But I can't randomly now go and say that D is equal to DC because nowhere did they actually say it. So we must quickly do a small little proof here. So how did we get to these sides that are equal? We firstly said that AB is equal to DC. Why? Because it was the opposite sides of my parallelogram. Then AB is equal to this DE given. Let's look there. AB is equal to BE and DE. So I still keep to my AB. That's now equal to both of them. And the moment that you sit with two that are the same, you can say, okay, so therefore DC will actually be equal to DE because those two are equal, therefore those two will be equal. And there's my DC and my DE. And it forms an isosceles triangle. So from there now, I can say that angle E3 will actually be equal to angle C. That will be equal to 56 degrees. Angles opposite equal sides. Right? Because we just proved these sides are equal. And from there, you just substitute D1, which is X, and I'm going to work with my interior angles of a triangle. So I'm actually going to say D1 plus E3 plus, let me just fill in my 56 there, plus C is equal to 180 degrees. Always give the reason. Interior angles of a triangle. D1 is an X, E3 is 56, angle C is 56, equals to 180. And this will add up to 112 degrees. And voila, therefore, X is equal to 68 degrees. So you see, you need to understand the basic properties of a parallelogram, and you need to know how to prove something is a parallelogram. If you know all of that, then you can continue trying to prove it. And as I say, there's no fixed way of proving geometry. So it's just self-confidence and trial and error. Sometimes you scratch it out and you start all over. Let's look at this one. It says here the triangle ABD. Okay, ABD. Now, I must admit, it's difficult, and I'm not happy with it if they just say ABD is an isosceles triangle. Because, you know, we actually have to apply a little bit of technical drawings here now by seeing that if it's an isosceles triangle, it means this side will have to be equal to this one. So it's not a super wonderful question. Triangle ABD is now isosceles. So unfortunately, we have to just visually look at it. And BCD, okay, BCD is also an isosceles triangle. So it means this side will be equal to that side. because you can see that would be the two longest sides. Then it says angle C is 75 degrees. So we fill it in. And ADB is equal to 30 degrees. So that's the only information we have. We can't work with a parallelogram because we have to prove that this shape is a parallelogram. Now you keep in mind, you know, these 5 options. We don't have any diagonal line. We have a diagonal here, but we don't have a line cutting through it. I don't really have equal sides, so I'm not going to work with opposite sides are equal. So from there, I see that we sit with now isosceles triangles and we sit with angles. So it's very possible now that I'm going to try and work with this one, to work with 2 pairs of opposite angles are equal, because it doesn't seem as if it's possible to work with any of the others. So that's how you analyze. That's how you start off. So from here, I'm going to mention here that, so I'm starting off here. So I'm going to say that triangle ABD is an isosceles triangle. And I'm going to say angle A is equal to angle B2 because it's angles opposite equal sides. I like to work with X. I'm going to say let angle A be equal to angle B2 is equal to X. So that's an X now, and this is an X. And then it's so much easier to just work with interior angles of a triangle. Then we can just say B2 plus A plus D2 will add up to 180 degrees. It's interior angles of a triangle. And then it's just X plus 30. That's 2X is equal to 150 if you take it over. Therefore, my X is 75 degrees. Lovely. Now we can fill it in. 75 degrees and 75 degrees. And voila. What do we have here? Angle C was given that it's 75 degrees. So now at least we're halfway there, because we can now say angle A is equal to angle C. So therefore, angle A is equal to angle C is equal to 75 degrees. But that's not enough, right? We need to also, because we need to have 2 pairs of opposite sides are equal. So we've got that one. Now let's work with the other one. BCD is an, so it's our same thing, is an isosceles triangle. By the way, here, before I just say A is equal to C, I will just put in there that angle C is equal to 75 degrees, and that was given. Okay, so I'll just add that to my story. Now here we can say that angle C, because they said this one is equal to that one, so I can say that angle C is 75 degrees, that's given. So therefore, angle D1 will be equal to angle C is equal to 75 degrees, angles opposite equal sides. Now we'll just include there that it's BC is equal to BD. And fill it in on your drawing. Please take note that you can't say B1 is equal to 30 because we haven't proved that it's a parallelogram. So we can't work with that at all at this stage. But now we're just going to work with interior angles of a triangle. So I'm going to say B1 plus D1 plus angle C adds up to 180 interior angles of a triangle. So B1 plus 75 plus 75 is equal to 180, and therefore B1 is equal to 30 degrees. So this one is equal to 30 degrees. Right, so we have it up until there. I think I copied another slide here, yes, so that we can now go from there. So can you see I just duplicated the information here that we just got from the previous slide. And yeah, we have those two. I think I've got everything in here. So why I've done this is I want to show you now. Okay, in the previous slide, I just indicated that one with this because all these sides on, oh, they are. So why I did it like this, I want to show you two ways of proving now that this is a parallelogram. Right. So firstly, I'm going to say angle C is 75 degrees given. Angle A is equal to 75 degrees proven. So therefore, that one is, okay, so that one and that one is equal. So therefore, angle A is equal to angle C is equal to 75 degrees. Then I'm going to work with B1 plus B2. B1 plus B2 is 75 degrees plus 30. Because we already proved, I don't have to again say B2 75. And D1 plus D2 is 30 degrees plus 75, which is 105. Therefore, B1 plus 2 is actually equal to D1 plus D2. And from there, we can say, therefore, A, B, C, D is a parallelogram. Why? Because we just proved that two pairs of opposite angles are equal. So that's one story. Maybe this was Cheval's story. And we're going to see maybe what is going to be Connie's story now. So I'm going to show you another method. So this is one method. I can also say here, BC is equal to BD. We said it's an isosceles triangle. AD is equal to BD because it's an isosceles triangle. Therefore, BC is equal to AD. Therefore, BC is equal to AD. So let's just look at it quickly. BC, this one, is equal to BD. It was given. And AD was actually equal to BD. So therefore, the top side will be equal to the bottom side. So you see where I'm going? Opposite sides are equal. Then I'm going to say D2 is equal to 30 degrees. D2 is equal to 30 degrees. That's given. And B1, Benny 1 is equal to 30 degrees. It was proven. Therefore, BC will be parallel to AD because it forms alternate angles. And therefore, ABCD is a palm parallelogram. Why? Because one pair of opposite sides are now equal and parallel. One pair of opposite sides are equal, and parallel. Right? So let's just look at it. So we just showed here that BC is equal to AD, and then we showed here that this side, this angle is actually equal to that one. So that means the sides will be parallel. So one pair of opposite sides are equal and parallel is your second method. Right, this is the last one we're going to look at. Let's first look at the given information. It says here, in quadrilateral. So we sit here with a quadrilateral LMNP. And let's look at all the given information. We sit here with E1 is 62, E1 is 62, P1 is 68, this one is 68. We sit with P2, which is 56. And further than that, FP, right? FP is actually equal to FN, So we sit here again with an isosceles triangle, and LE is equal to LM. So we again sit with an isosceles triangle. And from this, we must prove that LP is parallel to MN. So something is parallel if we can somehow, LP, it's a horizontal line. So if we can somehow prove alternate angles or co-interior or corresponding. So again, I'm just going to work with the given information. I can't see the answer yet. I'm going to say angle P2 is equal to angle N is equal to 56 degrees there. Angle P2 will be equal to angle N, and that will be equal to 56 degrees because it's angles opposite equal sides. Can you see in this triangle? That one opposite that one opposite that one. So it's going to be angles opposite equal sides. And I will just say, because they said that FP is equal to FN, right? From there, what can we do? We can now work with the interior angles of that triangle to figure out F2. So I'm going to say F2 plus P2 plus N is equal to 180 degrees. Why? Because it's interior angles of a triangle. And F2 plus, now you just add the 56 and the 56, equal to 180 degrees. So F2 plus 112 is equal to 180. So F2 is equal to 68 degrees. And you fill it in on the drawing. So that one is your 68 degrees. So I've got F2 is 68 and P1 is actually also equal to 68. Can you see that? So what does that mean? It means it will be a parallel line. So I'm just going to say here, and P1 is equal to 68 degrees because it was given. So because this one is 68 and that one is 68, it forms alternate angles. And then we can just say, therefore, LP will be parallel to AN because it forms alternate angles. Right, and then let's just look at the second question there, and then we will be done. Now, I filled in everything that we just proved, and we just proved that LP is parallel to MN. Now, for the second one, they say that we must now prove that LMNP is a parallelogram. Sure. So I'm going to start off with angle E, because now again you sit with 5 options of proving something is a parallelogram, and all we have is that that side and this side is parallel. So my story is going to start with P2, which is equal to N, which is 56. Angle P, which is equal to angle N, which is equal to 56 degrees, angles opposite the equal sides. Remember, I have now one pair of opposite sides are parallel. So I would like to somehow work with that. Right? So I'm going to work with, sorry, I lost the track here. Sorry, I don't want to work with that. I've already worked with that one. Apologies. I was nearly taking you through the whole step again. I'm going to work with E1 is equal to M1. E1 is actually equal to M1. Yeah, because we already worked there. I nearly wanted to start there again. Angles opposite equal sides. Then again, work with your interior angles of a triangle. I think you are used to it now. L plus 62 plus 62 equal to 180. Interior angles of a triangle. So angle L plus 124 is equal to 180. So L is equal to 56 degrees. And we just fill it in there. So this one is 56 degrees. And what can you see from this? We can see that opposite angles are equal now. So angle L is actually equal to angle N is equal to 56 degrees, right? So angle L is, where's my L? L is 56 degrees, angle N is 56 degrees, and we sit now with M2. Let's see if we can't work with that as well. We've got this one and that one is equal. Yeah, I can't really work with sides are equal, so I'm not going to try this option, you see. So it's going to be easier for me to actually try and work with opposite angles are equal because I already have that one now. Yeah, so I'm not going to try and work with my parallel line. I'm not going to use that option. So let's see if we can't somehow now prove that this M1 plus 2 is equal to that one. Then I can just work with two pairs of opposite angles are equal. So let's see, M2, we can actually say, because we know this is parallel lines, you know, from the previous proof. So I can do this. I can say E1, angle E1 is equal to 62. That's proven. We already proved it. So M2 is equal to E1 is equal to 62. Alternate angles, because LP is parallel to MN, you know, from the previous proof. So therefore, M1 plus M2 will be equal to 62 plus 62, which is 124 degrees. From there, let's look at P1. P1 is 68 degrees, proven. We already did it in the previous slide, proven. And P2 is equal to 56 degrees, that was given. So therefore, P1 plus P2 is equal to 68 degrees plus 56 degrees, which is equal to 124 degrees. Voila. So that one and this one is 124 degrees. So we're done. So then we can say, therefore, LMNP is a parallelogram, and my reason, two pairs of opposite angles are equal. Okay, so you see how you analyze from the given information to the possibilities of proving a parallelogram. That's how you decide. Thank you so much for joining.